The next topic of this section is inverse function. In order to talk about inverse functions, first we need to know a special type of function, which is one-to-one function. I want to recall what is a function again. A function is basically a relation, right, which for each input, which is for every x value, it corresponds to exactly one output value. Correspond to exactly one output value. So that is something that we want to review. For every x, there is only exactly one y value. One-to-one functions is basically the other way around has to be the same also. Meaning for every output, okay, for every output, it must be correspond to exactly also one input value. So that way, you have only one directions. For example, if you have an x value, okay, and then if you go to one directions, exactly one y value. And to be one-to-one functions, this y value must come back what? Exactly one x value as well. And the reason why is because in mathematics, we want to know if we go one directions, we want to make sure we know how to come back where we originally started. For example, if you are adding two numbers, you can basically what? Do the opposite operation, subtraction. Multiplication will be divisions. Square it, you can square root it, going backward. Okay? So let's try to understand this definitions. What is a one-to-one function? So look at the example. Determine the set of order pairs represent a function. If it is a function, we want to determine this is one-to-one function or not. So to determine is a function or not, and all we have to check is what? Every x value must be different. If every x value is different, that means each x value corresponds to exactly one y value. So example A, when I look at it, all my x values are different. Right? All my x values are different. So therefore, it is a function. Now, to make sure this is a one-to-one functions, I have to make sure also what? All my y values are different. That means all my y value will be correspond to exactly one x also. So when I look at it, -6, -4, -2, 0, 2, 4, 6, all my y values are also different. So therefore, this is one-to-one function. So now I can say that it is a function or not? Yes, it is a function. And we can even go further. This is what? One-to-one function. So we can indicate that this is one-to-one. So checking the next example, when I check my x value, the x variable in order pairs, 4, -2, -1, 0, 1, 2, 4. So all my x values are different, so therefore this is a function. Because if all the x value is different, that means each x value can only go to one y value. So therefore, yes, it is a function. Now we want to check it is one-to-one function or not, which is checking the other way around. All my y value must be what? This correspond to exactly 1x. Now, this already fell right here. -8, my y is 8, but we have two different what? X value. So therefore, this is not one-to-one. So let me give you a graphical example of this, two cases. Right? Both of them is a functions. The first one will be like a linear equations, a line. For a line, you can see that for x for each x value, there is exactly one y. And for each y, there is exactly one x also. So that's one-to-one function. And for the second case will be something like this. You have like a parabola, right? Parabola, for each x, there is exactly one y. But for the y value, for one y value, it will go back to what? Two different x. So that cannot be one-to-one function. Okay? It is a function, but not to one-to-one anymore. So saying that, oh, this will make it easier, right? Because I already pointed out already. So this giving you a graph, which is a line. So for a line, I can see that for every x value, there is exactly what? One y value. So therefore, yes, this is a function. And also, for every y value, there is exactly one x value. So therefore, this is also one-to-one function. For the next one, is this a function or not? This graph is not a function because for one x value, it has what? Two different y value. So this is not a function. Since this is not a function, I cannot talk about this as one-to-one or not, right? Because one-to-one is only for one is a function. So you can say that it's not one-to-one. Next, quadratic. So we already know that it's quadratic earlier. I mentioned it. This is what? A one-to-one function. It is a function because for every x value, I have only exactly one y value. Right? It may be a different x with the same y value. So therefore, this is a function. But however, for one y value, it goes to what? Two different x. So therefore, it is not one-to-one. And lastly, a circle is not a function because for one x, you can clearly see there's what? Two different y values. So it's not a function. So now, hopefully you get an idea of what is a one-to-one function means. Only if it is one-to-one functions, then we can talk about the inverse function. Okay. So this is the important part. To talk about inverse functions, the function must be one-to-one function first. In this sections, for our course, we don't have to worry about algebraically checking the given functions are one-to-one or not. But you should be able to tell graphically the functions of the graph is one-to-one function or not. That's what we practiced on previous example. Okay, so let's go back to here. If a function is one-to-one functions with the order pair x, y, then the inverse functions, okay, inverse functions, the notations of inverse function will be what? -1 power. It's not -1 power, it's inverse function notations. And then what happened is what? The order pair flip around. That is very important because the x and y interchange it. Okay. Here, in terms of diagram, this is what I want you to point it out. So let's say this is my x and a y, and then my function f of x that is equal to x plus 1. So what happened is a function is going this directions. Right? If I plug in 1, I put it into formula, so 1 plus 1 will become what? 2. So in functions, x is my domain, and my y is what? Range. But when we talk about the inverse functions, we are basically trying to go backward. So in the inverse functions, okay, we need to substitute this value 2 into the formula so that I will get back what? 1. So for the inverse functions, this 2 become my domain. And then 1 become my range. So notice that the original functions and the inverse function, their domain and range are flip around. So that's why when you see the inverse functions, the order pair become what? Y and X, which is you interchange X and Y from the original one. So if I want to find the inverse of this relations, then the inverse of this relation will be all my order pair will be flip around. Right? You'll interchange the domain and range. So it will become 4, 0 for the first point, 7, 1 the second point, 10, 2 the third point, and 13, 3 the fourth point. That will be the inverse of the original order of pairs. So now we want to use this idea and graph the original functions, given original function. So here is the graph, and we're going to try to use these points on the graph, okay, to get the inverse graph of this function. Because these are good points, right? Notice that I'm using all good points right here. So the first point, this is -5, -7. So if I want to talk about the inverse of this point, the point will become -7, -5. So which will become right here, -7, -5. That will be right here. So this first point will be right there. And then the next point, which is this one, that is my original point is -3 and -3. So when I do the inverse of this, since -3 and -3, if you interchange X and Y, it will still gonna become the point right here. So it doesn't move for this point. In the next point, which is right here, that is -1, 1. So when I find out the inverse of this will become what? 1, -1. That will be down here. And going to the next point, which will be this one. This one is 3, and then comma 3 again. So if you interchange X and Y, right, this point is still right here, doesn't move anywhere. Next point, that is 5, 4. So when you interchange X and Y, that will become 4, 5, which will be right here. And finally, the final point, the last point, in this case, it is 6, 8. So when I interchange X and Y, that will become 8, 6, which is right here. Oh, 8, 6. Yeah, 8, 6, which is right there. So now by connecting all these points together, this will help me to get my inverse graph. There you go. So if this is my function, original function, then this will become my inverse function. So the idea of the inverse function is very straightforward. If this function is one-to-one functions, your domain and range basically flip around. So pause it and then try this example. Okay. So first, I'm gonna use these point right here. Here's a point. 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 here's a point, and finally here's a point. So the first point, this point is negative 3, negative 4. So when I look for the inverse of the point, that will become negative 4, negative 3, which is going to be right here. And the next point, that is negative 2, negative 2. So this point will not go anywhere. It will be staying right here also. And if I look at the third point, that is negative 1, 0. Right? The third point is negative 1, 0. So when I look for inverse, it will become 0, negative 1, which is going to be right here. And the next point is 0, 1. So when I find the inverse, that will become 1, 0. And this point, that is 3, 2. So when I find the inverse, it will become 2, 3, which will become right here. And the next point is 4, 6. So when I find the inverse, that will become 6, 4, which is right here. And the last point is 5, 10. Right? The last point is 5, 10. So when I talk about the inverse of it, it will become 10, 5 right here. So now we can graph this. So these 3 points is the straight line. Right? These 3 points is a straight line. And these 3 points is also a straight line. And this middle 3 point is like a square root curve. So it will be curved like this. So that is my inverse function. Here's the functions, here's the inverse function. So graphically, this is how we look at the inverse functions, right? Inverse of the graph. And we're going to use this idea when we start talking about the exponentials and logarithm because they are inverse of each other. So now that we know what's graphically happening, we want to find out algebraically, okay, algebraically the inverse functions. So first, we replace the function notation with f of x with y. That way it will look like an equation, which is much easier to solve equation, right? Notation. And then second step is the important part, which is we're going to be interchanging x and y. That's where your domain and range in your x and y flip around. That's the conceptual part that we are applying to it, right? Your domain and range flip around. And then after that, we will solve for y and then replacing y with inverse function notations. That's the process of trying to find out the inverse function. So let's move on. Step 1, replacing the function notation f of x with y. So that y is equal to 5x minus 3 over 8. And the next step, I'm going to be interchanging x and y. So that means that's basically applying the conceptual part. So my y become x, my x become y. And then finally, next step, we're going to solve for y. So when you're solving it, depending on the equations, you're going to solve it along with it. So in this case, this is linear equation. So I multiply both sides by 8, which will become 8x is equal to 5y minus 3. Adding 3 to both sides. And finally, we divide it by 5. So 8x plus 3 over 5. Which now we can rewrite this in terms of function notations, which is 8x plus 3 over 5 is equal to, now it will be inverse function notation, which is f inverse of x. So now we found out the inverse function. So let me convince you this way, okay? Let's say f of 1. That is 5 times 1 minus 3 divided by 8, which give me 2 over 8, that is 1/4. So according to the inverse functions, if I replace this 1/4 into the formula of inverse function, I should be able to get my outcome is 1. Right? Because right here the order pair is 1/4. So if I plug it in 1/4 into my inverse function, my output must be 1. So let's try to test that. So f inverse of 1/4. So that is basically 8 times 1/4 plus 3 divided by 5. So 1/4 times 8 is 2 plus 3 divided by 5, which is 5 over 5 is equal to 1. So you notice that this is 1/4. So, oh, my bad, sorry, I wrote it wrong. Okay, so it'll be what? 1/4, and the output is what? 1. So the inverse functions and original function, they are domain and range basically flip around. So hopefully with this you convinced that the process, it does work on finding out the formula part. So try to pause it and then do the next example. See you can solve a different types of equation or not. Right? Do you remember how to solve it or not? So example 7, finding the inverse of this one-to-one functions. So g of x, first we rewrite with the equation, replace with y. So that will be y is equal to 5th root of 3x minus 2 minus 1. And the next step is interchanging the value of the x, the variable x, and the variable y. So the variable y become x and the variable x become y. Now we're going to solve for y. So what we are solving is solving a radical equations. So when we solve for radical equations, we need to isolate one radical term by itself on one side. So therefore, I need to add 1 to both sides first. And to get rid of this radical, now we raise the power the same as index. This time it's a 5th root, so we raise the power to the 5th power on both sides. So x plus 1 to the 5th power, and then 5th root of 3y minus 2 to the 5th power. So you don't need to multiply it out, so you can just write it down. X plus 1 to the 5th power is equal to 5th root and 5th power, they cancel out, it will become 3y minus 2. Don't forget we are solving for y, so therefore the next step that we're going to do is add 2 to both sides. So when I add 2 to both sides, it will be x plus 1 to the 5th power plus 2 is equal to 3y. And finally, I'm going to divide both sides by 3, so it will be x plus 1 to the 5th power plus 2 all over 3. Which is now, my final step is rewriting with a function notations. So it will be x plus 1 to the 5th power plus 2 over 3, that is equal to the inverse function notation, which is g inverse of x, because our function is g function this time, right? Not f of x. Finally, the last example, rational functions. So as usual, first step will be what? Replacing the function notation with y. So y is equal to 2 over x plus 2. Now we're going to interchange x and y. So the variable y replace with x, the variable x replace with y. And we're going to solve for y. So multiply both sides by the LCD, which is y plus 2. So this will become y plus 2 times x, and then 2 over y plus 2 times y plus 2 over 1, right? So this will become 2 is equal to y plus 2 times x. So I can divide both sides by x. That will give me y plus 2 is equal to 2 over x. And then I subtract 2 to both sides, 2 over x minus 2. Finally, I rewrite with the function notation g inverse of x, that is equal to 2 over x minus 2, and that's my final answer. And this concludes this section.